Okay, let's take a look at section 7.4, quotients, powers, and rationalizing the denominator. When you have square roots, such as the square root of 2, square root of 3, square root of 5, they are irrational numbers. If an irrational number is in the denominator of a fraction, it's customary to rewrite the fraction with a rational number in the denominator. So that means that you will not have a radical in the denominator, and that's called rationalizing the denominator. And to do that, you'll just multiply numerator and denominator by the power in the denominator. I have a pen there. So we'll multiply by the square root of 5, square root of 5. That'll give me the square root of 15 in the numerator and 5 in the denominator, because 5 times 5 would be the square root of 25, which is 5. Okay, number 2, when we take a look at number 2, that looks like it is the third root of 5 over the third root of 9. Now I know 9 is a perfect square, so I'm going to reduce that, or rewrite that actually as 3 squared. Now remember, when you rationalize the denominator, you want to get whatever the radicand is, the power on the radicand, to match the indices. So that means I only have to multiply this by the third root of 3. Third root of 3. So I will now have the third root of 15 over 3, because I'll have the third root of 3 to the third, which is just 3. Number 3, now I have in the denominator the third root of 2. Remember, I have to build that up, so I have to have 2 to the third power. So I will have the third root of 2 squared. So in the numerator, I will have 3 times the third root of 2 squared over, and this is what it would look like, the third root of 2 to the third. The third root of 2 to the third is simply 2. So I have 3 third root of 2 squared, or 4, doesn't matter, both are correct, you can write it either way. So to rationalize a denominator with a single square root, multiply by the square root. If the denominator has a cube root or a larger index, build the denominator to a rational exponent of x over x, meaning the power over the index, so that the power and the index are the same. So now, when we take a look at number 4, that looks like I have, let me rewrite that, it's not very legible, 2 over the fifth root of x to the third y squared. So I want to build that up so that I have x to the fifth, y to the fifth, and then the fifth root. So the fifth root of x squared, y to the third. So the fifth root of x squared, y to the third, this gives me 2. Fifth root of x squared, y to the third, over the fifth root of x to the fifth, y to the fifth. So when I'm finished, my answer will be 2 fifth root of x squared, y to the third, over x, y. Taking a look at number 5, I have looks like the fourth root and the sixth root. So I'm going to multiply. You don't have to worry about the 3. That's not under the radical, so you don't have to include that. The sixth root of x to the third y squared. Sixth root of x to the third y squared. So now I will have 2 fourth root of 2 to the third x to the third y times the sixth root of x to the third y squared, and that's all going to be over 3xy. Now I told you in class I don't want you to leave two different radicals with two different indices in your answer. So we need to handle this situation with the numerator. Again, we're not going to worry about the 2, that's not under a radical. So I'm going to rewrite this as 2 to the third x to the third y raised to the 1/4, then times x to the third y squared to the 1/6, and I have a 2 out here, I'm sorry, and then 3xy. So now take a look at the indices. Right here. Oops, I wanted to change that color to yellow. So that 1/4 and 1/6 should be 1/4. So take a look at that 1/4 and the 1/6. Now we need to make that a common index. So the least common multiple on that is going to be 12. So I'm going to rewrite this as 2 times 2x to the third, 2 to the third, x to the third, y, raised to the 3/12, and then I will have x to the third, y squared raised to the 2/12 all over 3xy. Now once I have them as 12ths, I'm going to take and rewrite those, bringing down the power from the numerator. So I will have 2 times 2, 3 to the third, it's going to be 2 to the 9th, x to the 9th, y to the third, all to the 1/12. And then in the second one, I will have x to the 6th, y to the 4th, all to the 1/12, over 3xy. Now because they all have the same indice, 1/12, I could put them all into the radical and put them all back under the radical and simplify them. So I'm going to have 2 to the 12th root, I have 2 to the 9th, x to the 15th, y to the 7th, all over 3xy. And now you should look at that and say, can I simplify that further? And you should recognize that you can bring x to the 12th out. So you have 2, that's going to be an x because the 12th root of x to the 12th is x. 12th root of 2 to the 9th, x to the 3rd, y to the 7th, all over 3xy. You'll have a lot of practice with those. Next, number 6, I have the third root of 10x squared divided by the third root of 5x. This one's a little easier if you remember the rule that said the square root of a over the square root of b is equal to the square root of a over b. Because once they're under that same radical, then you can simplify that. So this becomes the third root of 10x squared over 5x. So now you can reduce that to the third root of 2x. And this is another one of those procedures that you just have to practice and practice and practice to become proficient at. Next, simplifying radical expressions. You can cancel a factor if and only if it is a factor of every term. So keep that in mind. We're going to be using this as we use the quadratic formula, so you have to remember how you can cancel. So if we're going to simplify this, I have 4 minus, now the factors of 12 are 4 and 3. 4 is a perfect square, so I'm going to bring out 2 root 3 over 4. Now, This is when I'm looking at what can I factor out. I can factor out a 2 from every term. That leaves me 2 minus the square root of 3 over 2 times 2. So I can cancel those 2's. That leaves me 2 minus the square root of 3 over 2. In number 8, again, I have minus 6 plus the square root of 20. Square root of 20 is 4 times 5. 4 is a perfect square. Square root of 4 is 2, so that becomes 2 root 5 over negative 2. So in this case, I can factor out a negative 2. That's going to leave me with 3 minus the square root of 5 over negative 2. The negative 2's cancel, and I'm left with 3 minus the square root of 5. Number 9, let's see, where are you? Number 9, 27x plus the square root of 45 over 6x. So that's 27x plus 45 factors 2. 9 and 5, 9 is a perfect square. So that gives me 3 root 5 over 6x. So I can factor out a 3, and that will leave me 9x plus the square root of 5 over 3 times 2x. And I can cancel those 3's, leaving me okay, rationalizing denominators using the conjugate. We introduced the conjugate, I think, in section 7.2. Remember the conjugate, if I have the square root of A minus the square root of B, the conjugate would be the square root of A plus the square root of B. And the idea is that when you FOIL those middle terms will cancel, and what will happen is the denominator will become a rational number instead of an irrational number. So for the first one, I'm going to multiply numerator and denominator by the conjugate, which is 4 plus the square root of 3. So in the numerator, when I FOIL, I'm going to get 8 plus 2 root 3 plus 4 root 3 plus the square root of 9. And then in the denominator, I will have 16 minus the square root of 9. So in the numerator, that square root of 9 becomes a 3. 8 plus 3 is 11. I can combine the like terms in the middle, giving me 6 square root of 3. And in the denominator, I have 6 minus 3, which is 13. So number 2, I'm going to multiply again numerator and denominator by the conjugate. Square root of 6 minus the square root of 2. Square root of 6 minus the square root of 2. So this becomes, in the numerator, square root of 30 minus the square root of 10. In the denominator, because I'm multiplying by the conjugate, I know what's happening with those middle terms. I'm going to have the square root of 6, the square root of 36, which is 6, minus the square root of 4, which is 2. Now, if you FOIL those, you're going to see those middle terms will cancel. I'm skipping that part. I'm hoping that you see that. The square root of 30 minus the square root of 10 over 4. Number 3, I think this time I'll actually FOIL that denominator and make sure you see that. I'm going to multiply by the conjugate, numerator and denominator by the conjugate, which is x plus 5. X plus the square root of 5, I'm sorry, x plus the square root of 5. Numerator, when you FOIL that, x squared plus x square root of 5 plus x square root of 5 plus the square root of 25, denominator, x squared minus x square root of 5 plus x square root of 5 minus square root of 25. So in the numerator, I have that x squared plus 2x root 5, because there are 2, plus 5. And in the denominator, they cancel, so I have x squared minus 5. Now let's take a look at simplifying some radical expressions that look a little complicated, but handled correctly, they really are not. I'm just going to rewrite these in exponential notation, and then we're going to apply the power to a power rule, and you'll see that they're actually pretty simple that way. So I start with x to the 8th, y to the 16th, z to the 24th. Now, I'm going to take that first radical inside, 1/2. So I have all of those raised to the 1/2, and then again raised to the 1/4. So now we can think of this as a power to a power. I'm going to do it in 2 steps. First, I'm going to raise the 1/2 to the 1/4. So I'm going to have x to the 8th, y to the 16th, z to the 24th, all raised to the 1/8 power. Power to a power, 1/2 times 1/4 is 1/8. Now I'm going to raise each of those to the 1/8 power. So I have x to the 8th over 8, y to the 16 over 8, z to the 24 over 8. That gives me x, y squared, z to the 3rd. So it looks daunting, but it really isn't. It's really not too hard to handle at all. Let's take a look at a few more. Okay, number 2. And again, I have these radicals in the denominator, so I'm going to rationalize that by multiplying numerator and denominator by the 4th root of x to the 3rd, y, z squared. So in the denominator, that's going to give me the 4th root of x to the 4th, y to the 4th, z to the 4th. In the numerator, now I'm going to have those 2 different radicals to think about. And I'm going to have to get that common index. So now rewrite those terms in the numerator in exponential notation. So x squared, y, z, all raised to the 1/3, and then x to the 3rd, y, z squared to the 1/4, all over x, y, z. Now your common index is going to be 12. So that's going to become this x squared, y, z raised to the 4/12, and then x to the 3rd, y, z squared raised to the 3/12, all over x, y, and z. Then bring that numerator, the power in the numerator, down inside the parentheses so that we have x to the 8th, y to the 4th, z to the 4th, to the 1/12, and also then x to the 9th, y to the 3rd, z to the 6th, to the 1/12, and again it's all over x, y, z. So now you have all of those under the same index, and you can combine those terms. So you're going to have x to the 17th, y to the 7th, z to the 10th, and that's going to be the 12th root of x, and then x, y, and z in the denominator. The only one you can simplify is the x, so you bring out one x, and then you'll have the 12th root of x to the 5th, y to the 7th, z to the 10th, all over x, y, and z. Just a few more. Okay, number 3. when I have minus 2 third root of 5 times minus 2 third root of 5. We're multiplying what's outside together first. That's going to give me a 4. And then I have the third root of 25 or 5 squared. Either is correct, it doesn't matter. Number 4, now we want to think about writing it in the least possible index. So I have, for this one, x squared raised to the 1/3 raised to the 6th. So here it's just a power to a power to a power. So we just have 2 times 1/3 times 6, which is 4. So this just becomes x to the 4th. You may want to pause the video now, answer the next few questions, whether they're true or false. I'll put the answers up and then you can check them. A is true when you multiply that denominator by the square root of 2. Actually, we're not going to do that. This one's simple. We're going to rewrite it as 6 over 2. And that's going to be the square root of 3. B is also true. Multiplying that denominator is going to give you 2 root 2 over 2, which becomes root 2. C is false. D is true. E is false. And F is true. That's the end of the video. Hopefully, I will see you tomorrow, and we will do the homework in class. Have a good evening.